of DBMS, from where sure shot 100% sure questions are coming. 100% sure, I am telling you. Because here this is the topic I am showing you one by one question. As you can see this question, I hope you are very much habituated with this type of question. Whatever exam you are preparing, UGC NET, GATE, SET, PhD entrance, school, college exam, wherever, whatever you are preparing, this chapter is a most important chapter. But students are always getting confused in this type of questions. And I will take through you that easy to difficult. All the questions we are going to solve here in functional dependency. How to identify candidate key. After that, what is prime and non-prime attribute. Then how to identify the normalization, first normal form, second normal form, third normal form, BCNF, what is 5NF, what is 4NF, how to do that. Then next one is lossless, lossy and dependency preserving. Here though most of the time students are getting confused how to do lossless, lossy, dependency preserving. These all the questions we are going to solve now with concept. I will think that you don't know anything, because I saw that maximum time students are getting confused in this type of question. Different types of question I took here. If you know that all these things, then no problem, you can leave the class. If you have any confusion in this area, then definitely stay tuned with me till the end. And if you are new to this channel, then definitely subscribe to the channel, click the bell icon to get all the latest update, notification, and to be connected with Unified Study. Because here you are going to get this type of all questions, this type of all topic, all question, wherever it is important for you. All these things I am going to discuss with you. Okay, chalo, let's start without wasting any time. I hope I am audible, visible. The first question is that first of all I will ask you question. After that I will help you to understand how to do it. First of all, you need to understand what is functional dependency, how to identify functional dependency. Because it is a tour. You are going to in a tour that yes, one by one, step by step. At least if you don't know, then also your all the concept will be clear. Definitely. Hi Ambedkar. Can you tell me that here everyone that which one is the correct answer? Because this is the basic topic. First of all, you have to know how to identify functional dependency. Which one is correct? How to identify functional dependency? Here X, Y, Z, 3 tables are given to you. Now in these 3 tables you have to tell me what are the functional dependency valid. Yes. Answers are coming. Option C is correct answer, but why? Question is why? How to do? It is the easy way I will tell you that try to understand conceptually, okay? Then you will never forget. Think that my name is Priyanka. There are so many Priyanka. When I take the birth, then at that time every father and mother was trying to give their girl name Priyanka. So that's why Priyanka is everywhere. Now when I studied in school, there also in a one class there was multiple Priyanka. In one apartment there are multiple Priyanka. That is a common thing, right? So it is possible that in a class there's roll number 1, that name is also Priyanka. Roll number 4, that name is also Priyanka. Roll number 30, that name is also Priyanka. Is it possible or not? Yes, this is possible. Right, this is always possible, right? Definitely this is possible. Now see that here if I am telling ki roll implies name, is this hold or not? Is this hold or not? If you am thinking you. So roll number 1 Priyanka, it is roll and it is name. So is it holding or not? Yes, this is holding, because although here for roll number the name is same, no problem, but roll numbers are different. That's why this is holding. That's why if I am telling roll number implies name, is this holding? Yes. But if I am telling that here ki roll number 1 name is Priyanka and roll number 2, here also again I am telling another ki roll number 1. Again another one ki another in this table only I am trying to insert ki roll number 1 name is here, what is the name, ki Rumpy. Here I can see that last comment from Rumpy. Again I can tell you ki roll number 1 Susuma. Roll number 1 Susuma. Is this possible? Is it possible? Think it. This is never possible, right? In one class, roll number 1 can be one student only. Roll number 1 cannot be Priyanka. Roll number 1 cannot be Rampi. Roll number 1 cannot be Susuma. It is never possible. That is the main point of functional dependency. This is the main point of functional dependency. You can see that. Here whenever I am telling X implies Y, is it holding or not? You check these two column. Here in the X, roll number 1, think like that, ki 1, 1. Same value is present here. For 1, 1, there is same value. 2, 3, there are different, so here are different value. No problem, that's why X implies Y, hold. No problem here. But Z implies X. Is this holding or not? Z implies X. Whenever you are taking, what is the problem in Z implies X? Check it. The problem in Z implies X is this one. This is Z, this is X. You can see here AA, here 1, 1. That is means okay, for one roll number same names are there. But here BB you are telling 2, 3. Means it is like that ki roll number 1 Priyanka and roll number 1 Rampi. This is not possible because for this same BB value, here should be also same values. As the same values is not there, that's why Z implies X is wrong. And from here you can eliminate ki Z implies X is wrong. But X implies Z is present. Very interesting question. X implies Z is present. Why? Because now I am telling X is deriving Z or not. Check it. X is deriving. X is the main one and Z. X implies Z or not. For X you can see 1, 1. Here it is AA. For same value same. Roll number 2 name is B. Roll number 3 name is B. That is possible. In one class multiple Priyankas are possible. That's why here X implies Z is correct. But Z implies X is not correct. I took this example so that your all understanding should be clear. Right? Left hand side. So what is the trick I am telling you? The left hand side. Check the left hand side. In the left hand side, if there is no duplicate, if there are all different elements, then no problem. All are different elements, then definitely it will hold. If there are some repeated element, if there are some duplicate element, for those repeated element and duplicate element, always remember ki whenever I am telling that this implies this one, means in right hand side values should be same. As you can see 1, 1, here are same values. 2, 3, no problem, these are different values. Right? Yes. That's why I hope it is clear ki Y, X implies Y, it is holding. So from here I can 3 X implies Y hold and X implies Z also hold. But Z implies X not holding. This is the reason. I hope it is clear. You will never forget this, right? Clear? Pakka clear? Batao. Ha, clear. If it is clear, then tell me. It is another question. Then I want to see that yes, it is clear or not. 1 is duplicate in X, yes, duplicate, but with corresponding to 1, there is in the Y also same values, right? But I told ki roll number 1, Priyanka, roll number 4 can be also Priyanka, roll number 3 can be. When roll number 1, Priyanka, no problem. Roll number 1, here it is Priyanka. Roll number 1, here it is also Priyanka, no problem. Here it is 1, this is A, 1 also, this is also A, no problem. Right? Yes, good, good. Now tell me, what is the answer for this one? Tell me, what is the answer for this one? B implies A implies B, A implies C, A, B implies C, C implies A, B implies C. Think and answer. If you learn that, then you can establish, yes, I learned it. This is question number 2. Okay, you can write down key question number 2. This is the answer. Okay, answers are coming. Let me see you are doing correct or not. See that here. One by one. Roll number. This is 1. B implies A, holding or not. Check the B column. In the B column, there are any duplicate values. These are duplicate values. These are duplicate values. Corresponding to this duplicate value, in the A column, there should be same values. It is same values, 8, 8. This is also 10, 10, same values. So, no problem. This is no problem. Right? Yes. A implies B. Whenever I am doing A implies B, now it is, see that. Is it possible A implies B? See that. A, here are duplicate values, here are also duplicate values. So for that, 1, 1, same values, 2, 2, same values. No problem. That's why this is also holding. This is also holding. No problem. Now the third one, for this one, A implies C. The third one is telling you A implies C. Is it holding or not? For A, same values 8, 8. Here you can see 8 is telling 14. Here 8 is telling 16. It is creating a clash. This is creating a clash just like that. Okay, roll number 1 name is Priyanka. Roll number 1 name is Rimpi. No problem. That is not possible. This is not possible, right? Yes, definitely not possible. That's why it is not correct. Here also you can see it is 16 and 14. It is creating also clash. That's why this is also not possible. So A implies C, not hold here. Got it? Why not? Clear? I hope it is clear. Now you can see here third one. I will tell you one by one everything. You already got your answer. Ki third one is not correct. 1 and 2 is correct. You already got your answer. But still I am trying to clear your doubts. AB implies C. Is it holding or not? A, B together you have to think. It is 8, 1. This is 8, 1. This is 10, 2. This is 10, 2. 8, 1 together it is creating a cree. Here it is 14. Here it is 16. Again the same clash is happening. Again it is creating the same clash. That's why it is not hold. C implies A. Is it holding? Is it holding? C implies A. In the C column, check it. Is there any repetition? Here 16, 16. Here 14 and 14. So for 14 here is 8. For 14 here is 10. That is creating a confusion. That's why C implies A is wrong. This is the reason. B implies C. Is it holding? B implies C. Check it. For the B implies C also, you can see 1, 1. Here it is 14 and 16. It is creating a clash. Either both should be 14 or both should be 16. Same value should be there. As there is no same values, that's why this is also does not hold. So ultimately 1 and 2 is correct. All other are wrong. I hope after watching this, your all these how to identify functional dependency, this will be clear. I hope so. There will be no doubt in this functional dependency, right? हाथ उठा के बोलो हाँ मैम क्लियर. यस क्लियर हो गए. अभी now I will not do any mistake identifying functional dependency. At least in identifying functional dependency you will not do any mistake. I hope so. Right? एक बार like तो कर दो. Like. Yes. 1 like तो बनता है. And 1 share भी बनता है. You can share with your friends also. Yes. You can share with your friends also. Right? Chalo. Now do this. Here you can see. Now this is list 1, list 2. Here normalization. Now you will learn normalization with me like a such a way so that you will never forget normalization. You can't. Even also in your sleep also anyone is asking which normal form you can do it. Yes. Good. Okay. Some of you are giving answer, but I will tell you that yes, how to find out normalizations and what are the main thing. Here it is first normal form, second normal form, third normal form, BCNF, 4NF, 5NF. These are the theories. I will just telling the theories. After that I will tell you how to identify. See that, always remember one thing, always you have to take it from the higher order. Okay. I am taking a extra page so that I can explain you. Take it from a higher order. First of all, 5NF. If any dependency is in 5NF, means any relation is in 5NF, then automatically it will be in 4NF, it will be in BCNF, it will be in 3NF, it will be in 2NF, it will be in 1NF. So it is upper to lower. So always if upper one is satisfied, then lower one is automatically satisfied. Okay. Now one by one see that fifth normal form. So I am going from 1NF. What are the basic one? 1NF is the basic one. 1NF is telling you it is the basic normalization. Each stable cell should contain only single value. Means multiple value cannot be there. You are doing like that. I am telling in roll number is a one cell 1, 2, 3. These are not possible. So single value in single cell, that is 1NF. And one normal form eliminates the duplicate data, simplify the query. Any duplicate will be not there. There is no other restriction. Any other restriction is not there in 1NF. Okay. Now one by one restriction introduce. Second NF, one restriction introduced that it is not allowing any partial dependency. Now what is partial dependency? For that you need to know candidate keys. For this you have to know candidate key. What is candidate key? And after candidate key, what are the prime attribute, non-prime attribute? Any partial dependency is not allowed, means part of candidate key cannot determine any other non-prime attribute. Prime to non-prime is not allowed here. Just remember the keywords. After that I am coming to example. In 3NF, what is happening? 3NF is not allowing any transitive dependency. Not have any transitive dependency. What is the meaning of transitive dependency? Transitive dependency means non-prime to non-prime not allowed. Non-prime to non-prime not allowed, including prime to non-prime also not allowed. Whatever constraint is there in first, second normal form, that constraint is also there in third normal form. With that, one extra is added here. Now in BCNF, all left hand side should be candidate key or super key. Now come here. What happened? Here BCNF, whenever you are coming, all left hand side should be candidate key or super key. Any other than it is not checking. This is the super constraint. If whatever dependencies are given, I want to see all are candidate keys or super keys or not, I will not bother about any other thing. Because automatically here this extra, that is in 3NF constraint is coming, non-prime to non-prime is not allowed. This constraint is already there. Now in 2NF, extra another constraint is there, that is non-prime, prime to non-prime is not allowed. Here non-prime to non-prime also not allowed. Here any of these are not allowed, and this is only candidate key, left hand side should be candidate key or super key. This is only allowed, other than that nothing allowed. And 1NF means this is always key, always there will be single value and single there should not be any duplicate. 4NF, 5NF. 4NF means what? It should be in BCNF. lower one should be satisfied. Does not have any multi-valued dependency. It is not allowing any multi-valued dependency. Dependency should not be multi-valued. Like you saw that in previous example, one roll number 1 is telling Priyanka, again roll number 1 is telling Priyanka, means multiple values are there. So multi-value cannot be possible. That is telling multi-valued dependency is not possible. And fifth NF is focusing like that it is project joint normal form. It is also known as project joint normal form. Normally in exam hall they are asking only the theory from here. They are not asking that types of conceptual question. They are asking only theory. So it is project joint normal form and it is the highest level. So after this any decomposition is not possible. Okay, here joint dependency, it's implied that the candidate key is defined in 5NF. Relation must be in 4NF. The relation must not be further non-less decomposed. Means if you are decomposing it, it will be lossy. There will be definitely loss, means it is the smallest one after decomposition. You cannot decompose it more. If you are trying to decompose, then it will be lossy decomposition. We will learn lossy and lossless decomposition also we will learn. Okay. Yeah, let's come to example, because for this you need to understand what is this. By example only it will be very clear. So for this you have to identify first of all what are the candidate key. This is the first step. After candidate key, you have to know what are called prime attribute and what is called non-prime attribute. Then you have to do key prime to non-prime, non-prime to prime. What is the meaning? So for that, first of all, understand here you can see this question you can do through the theory only. Okay, this is BCNF. BCNF is implies when I am going with BCNF, key functional dependency implies candidate key, means left hand side should be candidate key. 5NF is this, 1NF, this is the 1NF you can see, and 4NF this one. It is through theory you can do it. But here you have to tell me what are the candidate keys. Because to do correctly normalization, first of all you have to know what are the candidate keys. If you don't know what are candidate keys, then you cannot do prime attribute, non-prime attribute, and you cannot solve normalization also. So this is the first step to do the normalization. How to identify candidate key? Candidate key means the attribute which one is able to determine all other attribute, and it should be the minimal set. It should be always the minimal set. Yes, option D is coming. Here also one trick is there. With that trick you can do it, but this trick will not always applicable. Some of the question you can apply, but always you cannot apply. You can see in the right hand side which one is not present. U, W, X, V is present. Y and Z is not present. Means anyone is not able to determine Y and Z. So definitely Y and Z should be my part of candidate key. Y, Z closer if I am doing, then it will be always key. Y, you can see that through the Y I can determine W, means Y then W. After that you can determine Z, already Z is coming. Then from the Y, W you have already determined, and from here can you determine any other thing? You cannot. These are only coming. But I have to find out ki everyone should come. So now I will add one attribute with this, that is U. Now you can determine U, you can determine V. So already U, V, W. Now you can see that X is VW can determine X. V and W can determine X. That's why Y, U, Y, Z is the candidate key. Okay. Same way from the option now you can eliminate this is not, this is not, this is not, because as YZ is not present in the right hand side, so YZ will be definitely the part of candidate key. Here in this option only YZ is present, means definitely this is my answer. But how to do, how to solve, just you can see that how to solve I am telling you, so that other questions you can do it. Here you can do by eliminations. How to do, as you find out key you, now you will see that who can determine you. X can determine you, means you can replace U with X. You will see that all will come. Definitely everyone will come. U, V, W, X, Y, Z. Again you can see who can determine X. You can see V, W can determine X. Right? So I can take V because W will automatically come. Don't replace V, W together. Try to check with V, Y, Z. If I am doing, then automatically V, Y, Z is coming, and from the Y, W is already coming. That's why no need to add here W. Only with V, Z you can get all other attribute also. U also coming. So that's why this is also your candidate key. Now you got the candidate key, right? After getting candidate key, you need to find out which one is my prime attribute, which one is my non-prime attribute. Prime means part of candidate key. What are the part of candidate key? U, V, you can see, X, Y, Z. These all are the part of candidate key. That's why this is called prime attribute. U, V, X, Y, Z. These all are the part of candidate key. Which one is not then? Only non-prime attribute is W. Only W is the non-prime attribute. U, V, X, Y, Z, these all are prime. W is non-prime here. This is the way you have to find out prime and non-prime. This is the first step. After that, now can you tell me this one, this relation is in which normal form? In this question only, now can you tell me it is in which normal form? This is the dependencies given and these are the relation given. In front of you only we did key what are prime attribute and non-prime attribute. Then what normal form it is? Which normal form? Can you tell me that? One by one check it. One by one check it. Is it in BCNF? See that 4NF, 5NF no need to check. You can check from BCNF because this type of relation they are coming from BCNF only. Is it in BCNF? For BCNF what was that key? Every left hand side should be candidate key. This is not candidate key. These are not at all candidate key. So it is not in BCNF. Is it in 3NF? Is this in 3NF? In 3NF, transitive dependency not allowed. That's why I have to check is there any non-prime to non-prime? Is there any non-prime to non-prime? You can see there is no non-prime to non-prime. There is no non-prime to non-prime because only one non-prime attribute is there. This is also prime, this is also prime, this is also prime, this is also prime. These all are prime. Yes, VW together is, W is a prime. This is not a total non-prime, and but X is also prime here. Always remember for 3NF and 2NF, for 3NF and 2NF, if right hand side prime, then no problem, this is allowed. Right hand side prime, this is allowed here in 3NF and 2NF. Okay. Acha, so non-prime to non-prime, I am not getting any one non-prime to non-prime, because right hand side, now you check. Right hand side, is this prime or not? This is prime. This is also prime. This is also prime. This is also prime. Ultimately, all right hand side is prime attribute or not? All right hand side is prime here. Now for 3NF, not only this, I have to check prime to non-prime also, because for 2NF I have to check it. Is it in 2NF or not? Is this in 2NF or 3NF? Both prime to non-prime, one thing I have to check. Is it anywhere keep this is prime to non-prime? Part of candidate key is determine any non-prime attribute. Yes, you are telling correct here. I was trying to see ki you are doing it or not. Here you can see that this one. Here is the problem here. This W is a non-prime attribute. This W is a non-prime attribute, right? Yes. This is a non-prime attribute or not? As this is a non-prime attribute means prime to non-prime, it is happening prime to non-prime. That means it is partial dependency. As this is partial dependency, Y is the part of candidate key and W is the non-prime attribute. So this is not allowed in 2NF also, in 3NF also. That's why this relation is in 1NF. This relation is in 1NF. Clear? Yes. How to check? This is the way you have to check. One by one whenever you are going. This is the way you have to check ultimately. So this is 1NF ultimately, because prime to non-prime means partial dependency is happening here. W is the non-prime attribute. Y is the prime attribute. Yeah, clear. Good. Then tell me. If it is clear, then tell me what is this. Then tell me what is this. With the question, always your concept is getting clear. I believe that. Ultimate 1000 times also you are doing theory, your concept will not clear. Whenever you are doing question, then ultimately your concept will be clear. Do this one. I am coming in 1 minute. My daughter came. I am coming in 1 minute. Yes, I am getting the answer from few learners. From few learners I am getting answer. Bharti, Vanita, Ranjini and Priya, Deepa is answering. Option 1 is the correct answer. Very good. Here also you need to check that which one is your candidate key. First of all, which one is your candidate key? You can see here which one not present. You can see here BC present, BC present, FH present, F is present, H is present, EG also present, EG also present, A is also present in the right hand side, D is not present. Only D is not present into the right hand side, right? So I will try with D. D closer if I am doing. Then am I getting anything? No. With D closer, I am not getting anything. So I will try with one extra, AD, if I am doing AD. So I can get A to BC. So A, BC. After that from the B I can see C, F, H. So C to F, H, B, C, F, H. Now F to EG. So I can add EG. After that all are coming, A, B, C, and D is automatically coming because D is here. A, B, C, D, E, F, G, H all are coming here. AD is the candidate key. Now you have to try, is there any other candidate key? I can see is A can determine E, E can determine A. So replace A with E, ED closer. You can get here E, A, B, C, D, E, F, G, H. Everyone will come automatically because as E is able to determine A, automatically others is coming. You can see that other will definitely come. Now you will see any other one is able to determine E. This is a process. Anyone else is able to determine E? Yes, you can see that F is able to determine E. So replace F. FD closer if I am doing, then you will see that FD, F2 you can see EG, E to A, automatically others are coming. Again A to BC, again F, H, all are coming. Now you see any other one is able to determine F. B can determine F. B can determine F. Now you will replace BD closer. If I am replacing BD closer, what is happening here? What is happening here? You can see B, D, then after that C, F, H, then automatically E, G, E to A, all are coming. Yes. Now anyone can determine B. Only A can determine B. Now it is a cycle, you can stop. These all are the possible candidate key. Always remember, if you are not doing all possible candidate key, then your answer will be wrong. 100% your answer will be wrong. You got it? These all are my candidate keys. These all are the candidate key here. AD is candidate key. ED is also candidate key. FD is also candidate key. BD is also candidate key. These all are the candidate key. Now you check here. Is it in BCNF? For BCNF, I have to check all left hand side should be candidate key. Is it key all left hand side is coming candidate key? No. This is not coming. So definitely this is wrong. Is it in 3NF? Non-prime to non-prime not allowed. So what are the prime attribute here? Prime attribute is A is prime, B is prime, A, B, E, D, F, all are prime, right? A, B, E, D, F, these all are prime attribute. Which one is non-prime attribute then? Non-prime is A, B, E, D, F, other than that C, G, H. These are non-prime attribute, right? C, G, H. This is our non-prime. B, C, D, E, F, G, H. Yes. Right. So now you see. Non-prime to non-prime. This one. CHG. CHG. This is actually non-prime to non-prime. This is not allowed in 3NF. So it is not in 3NF. Is it in 2NF? Prime to non-prime. See, remember one thing. Remember one thing, how D is prime, because it is the part of candidate key. Prime means part of candidate key. These all are the candidate keys here. AD, ED, FD. These all are the candidate keys. Part of candidate keys are called prime attribute. Okay. That's why A, B, E, D, F, these all are prime attribute. Okay. So you can see here now, always remember one thing. in 3NF, whenever you are checking, then non-prime to non-prime, don't do mistake here. Sometimes students are getting confused. Then non-prime to non-prime is also not allowed. Prime to non-prime is also not allowed. And in 2NF, non-prime to non-prime, this is allowed. But prime to non-prime, this is not allowed. This is in 2NF. Okay. And another trick I am telling you, if candidate key is only one attribute is there, like A, this is a complete candidate key. B, this is a complete candidate key. Then don't think that if I am telling A implies C, if this is a candidate key and this is a non-prime attribute, then don't say that ki ma'am here to prime to non-prime. Don't say that. It is not prime to non-prime. This is a full candidate key. If this type of thing is happening, if only single attribute is creating a candidate key, means it is in BCNF. Sometimes students are doing mistake here also. They are thinking A is also prime. Part of candidate key means when one candidate key making two or more than attribute. Okay, if it is a single attribute, then it itself is a candidate key. Then it is not a prime. Prime means always part of candidate key. When more than two attribute, more than one attributes are there, like BC together, AD together, these are part of candidate key. One single attribute is making candidate key means this is not at all treated as prime, this is full candidate key. Sometimes questions are coming, students are doing mistake here, so don't do that mistake. Okay. So what is happening here? Non-prime to non-prime, is it happening here? It is happening. You can see that BC here. This one actually I can write like that, A implies B and A implies C. Okay. So A implies B, this is actually prime to prime because B is also prime. It is not creating any problem. This is in 2NF. But A to C, this is non-prime. This is non-prime. Okay. As this is non-prime, that's why it is not in 2NF. Here also don't do mistake. Here also sometimes students are doing mistake. Here I am going to this page. So many confusions are coming because concepts are not clear. A implies BC. I can write like A implies B and A implies C. This is okay. But don't think that AB implies C means you can write A implies C and B implies C. This is wrong. Don't do that. Here it means that one mother have two child. One mother have two child. So mother can determine B also. Mother can determine another child also. But this means that two person together is determine one child. Like that. Ki mother and father together, you are telling ki mother and father together determine a child, then you cannot separate them. You cannot separate them. Ki mother only determine a child, father only determine a child. This is not possible. Don't do mistake here. So many confusions are coming in this topic. And that's why today I am taking this question because I saw multiple students have this problem. Got it? Okay. So don't do this mistake. Okay. A implies B, C implies D means candidate key 1NF means here just now I told this one key this question we was doing, right? Yes. So that's why here you can see as this is non-prime, it is prime to non-prime. So A implies C, this is happening part of candidate key is determining C. That's why it is in not in 2NF also. That's why it is not in 2NF also. Is that clear? Yes. Got it? Even also from here also you can see that this is also not happening. B implies C, F, G. This is also. For B implies C, F, G, or B implies C, B implies F, B implies H. These are also again non-prime, right? This is C is a non-prime attribute. H is a non-prime attribute. These all are non-prime attribute. So it is happening. Prime to non-prime is not allowed in 2NF also. That's why it is in 1NF, but it is not in 2NF. Clear? Pakka? Sure? Then tell me. Pakka? Sure? Clear? Then tell me. One by one I will increase your level. One by one your level will increase, and I am sure about that in this topic you will never do mistake. Now tell me. First of all, tell me what is the candidate key here. Can you tell me what is the candidate key here? In this question, which one is your candidate key? Can you find out? Batao, what is your candidate key? Find out the candidate key. Okay, Deepa, Sri is telling key A and E is your candidate key. Achha. Then which normal form it is? Then tell me which one is the correct answer. Which normal form it is? Here you can see the trick will not applicable here. A is also present, B is also present, C will also present, D is also present, E is also present. All are present in the right hand side. Now which one is your candidate key here? So trick will not apply. Here you have to try A closer. Whenever you are doing A closer, A to B, C, B to D, C, D to E. A is your candidate key. A is already your candidate key. Now B closer if I am doing. B to D. Is there anything coming? No. Nothing is coming. B to D, it stop. If I am adding here C, then I am getting here C. C, D to E, E to A. So means B, C is also my candidate key. Here also so many students have a confusion. You are thinking, ma'am, candidate key is the minimal set. Minimal set means you started counting. Ma'am, A is the one attribute. So CB is two attribute. Then A is only my candidate key. CB is not my candidate key. This question are also coming. Are yaar, samjho. Minimal means not like that you are counting the number of attributes. A alone can determine everyone. That's why A is the candidate key. If I am telling AB, is it candidate key? No. Whenever you are adding something extra, then it is a super key. But then why CB is candidate key? Because if I am taking C alone, C cannot determine all. If I am taking D alone, D cannot determine all. D not B. If I am taking B alone, B also cannot determine all. That's why CB together is able to, this is the minimal set. CB together making a minimal set, which one is able to determine all other attribute. That's why CB is also candidate key. Don't count the number of attribute. You cannot take AC, AB. This is you cannot take. Because A cannot be present. Okay. So now you see that CB I got it. Is it CD? CD is also candidate key. C, D, E, A, B, all are coming. Only C you cannot. Only C is not able to do. Only D also not able to do. That's why CD is also candidate key. E to definitely candidate key. E, A, B, C, D. So ultimately these all are candidate key. A is also candidate key. BC candidate key. CD candidate key. E candidate key. These all are the candidate keys here. So ultimately this is in BCNF. This is also in BCNF. This is also in BCNF. Only problem is here. This is not in BCNF. Only problem in here. Because these all other are making candidate keys. Left hand side candidate key. Only the problem is here. That is B implies D. B implies D is what? B implies D is actually D is the prime attribute. D is prime attribute and B is also prime attribute. So it is ultimately prime to prime. Prime to prime is allowed in 3NF. Prime to prime is allowed in 3NF and it is allowed in 2NF also. That's why this will be in 3NF. So your answer will be 3NF. Got it? How to understand? These all the questions are selectively I have taken this question so that your all concepts should be clear. All concepts should be clear. It is in 3NF. Clear? Yes. Good. Achha, now batao. Now do this. Find the highest normal form of this relation. Tell me, what is the answer for this one? Find the highest normal form of this relation. This is a relation given. You have to tell me what is the answer. BCNF? Not. It is not in BCNF. How? It is not in BCNF. It is in 3NF because it is creating problem, right? Previous question, B implies D is creating problem. B implies D. B is the prime attribute. This is not the candidate key. Only B cannot determine. B is not a candidate key. If you are doing B closer, B, D, anyone is not coming. Okay. B is not a candidate key. That's why it is 3NF. All other is in BCNF, but this one is creating problem. Left hand side should be candidate key. This was creating problem, right? And for this question, now you all are getting confused. Yes. So here, those who are telling 1NF, they are wrong. 2NF is the correct answer. Here also very conceptual. Yes. Here also very conceptual. You can see that. Here you are getting AC is a candidate key. AC if you are getting A, C, Then after that B, because AC to BE you are getting here. Now BE is already there, BC to D. So A, B, C, D, E is coming. AC is your candidate key. Now you will tell me, as AC is your candidate key, so this is no problem. But here I am getting non-prime to non-prime because prime attribute is A and C. This is non-prime to non-prime. B implies E. This is creating non-prime to non-prime. That's why it is not in 3NF. But what about 2NF? Is it in 2NF? For 2NF, now you will tell me, ma'am, here BC implies D. BC implies D. You will tell me, ma'am, this is prime to non-prime. No, this is not prime to non-prime. Prime means part of candidate key. It should be the proper subset. Here proper subset means AC is my candidate key. Proper subset means either A or C. But B, C together, it's not a proper subset. B, C together is not a proper subset. If you are telling C implies D, then it is not in 2NF. That means it is prime to non-prime. Then it is not a 2NF. But as the B is combined with this, that's why it is not a proper subset. As it is not a proper subset, that's why it is in 2NF. This is the reason it is in 2NF. This concept is very, very important. Maximum students will do, 99% students will do, it is in 1NF, and that is a wrong answer. It is in 2NF. Got it? Clear? So I hope your all normalization question you can do now. There will be no problem in normalization. Everything clear in normalization, I hope so. Yes. Everything clear? Pakka? Sure? So then let me know in comment section. My daughter came, so I cannot continue that today lossless lossy. I was thinking lossless lossy I will continue. But as so many students are getting this problem, that's why I thought let's clear this concept today, so that later anyone will not face any difficulty. At least identifying, you learn everything, identifying how to identify dependency, how to identify candidate key, what is prime, non-prime, and how to identify normalization, how to identify BCNF, 3NF, 2NF, 1NF, and what is 4NF and 5NF. This is all the concept I hope clear from today's class. And if it is clear to you, I will request you try to share with your friends also. Those who are not able to understand, those who are struggling to understand this topic, I will request share them so that they can also learn. And regarding 4NF and 5NF, remember this topic. If 4NF does not allow multi-valued dependencies, and 5NF you cannot further decompose it. And if you like it, if you interested, then definitely in the next class I will explain lossless lossy and dependency preserving, which is the next important topic. From lossless lossy and dependency preserving also, lots of students have so many confusion. If you are interested, then in the next class I can explain this lossless lossy and dependency preserving topic. Then I think your total concept will be clear. Okay, chalo, bye everyone. See you again in the next class. My daughter came, she is shouting, so I am going. I will take in the next class. Okay, chalo, bye. And paid learners, 6 PM we will meet. 6 PM expected MCQ we will do. Bye.